Hello and welcome to an additional presentation of the class material from class 21 and 22 on probability and statistics. You can use this video if you perhaps missed class or missed portions of the class session, or if you would just like an additional presentation of the material to help you as you are studying. Now, one of the strengths of the supply chain management program at Bauer is that our supply chain management students become very skilled at analyzing data, and some of that analysis involves statistics. These skills in data analytics is becoming increasingly important, not just in supply chain management, but in every career. In almost every major, in almost every career, employers are looking for managers who understand data and understand how to use data in very smart ways to be able to help manage their business. Now, within our class and within this online presentation of the material, I am going to teach you these concepts, these probability and statistics concepts, in a way that is useful and fun, and that I really believe is within the reach of every student within this class. This is the way that we in supply chain management will introduce statistics in our classes and reinforce those concepts when they come up. Now, many times when we hear the word statistics, many of us will zone out. I want you to make a very special effort to stick with me today as I walk through these concepts. Here are some of the benefits that you can get if you will help pay attention with me today. If you can pay attention, you will, first of all, do much better on our final exam, which is exactly what we, the instructors, would like for you to do. We want you to do well in the class. You really can learn this because I am going to teach it to you the easy way. And if you can learn these concepts today, then you really will look like the smartest person at your first job, no matter what your major is. You see, these statistical concepts that I'm going to teach you today, these are the ones that are going to differentiate you from others of your colleagues in any of your careers. These are the same concepts that are used by marketing professionals to assess the effectiveness of marketing campaigns, by sales professionals to accurately predict sales volumes and profit margins, for accounting and finance to be able to predict probabilities of hitting key KPIs that they're going to be reporting to the boards of directors, for entrepreneurship to deal with all of the variability that happens in starting a new business, to be able to maximize revenue while minimizing cost. And of course, within supply chain management, there are many applications as well, which if you become a supply chain management major, you'll learn in our classes. While the data analytics that our students learn is focused on improving business performance and reducing costs, if you can learn even the basic statistical concepts, just those concepts that I'm going to be teaching you today, then you may be qualified to be able to move in to a very exciting job similar to this one.
Hey Riley.
Hey Keith.
So Riley is a statistician at ESPN, the sports network broadcast to sports fans around the world. So Riley, what exactly is a statistician?
I would say a statistician is anyone that analyzes numbers looking for trends.
So give us the Cliff Notes version of what you do here at ESPN.
Well, I'm a production researcher, which means that every night I meet with a group of producers, directors, anchors, and come up with a way to tell stories about sports using numbers.
So it's almost like plugging in a math equation.
Kind of.
So what you do helps sports fans create a deeper picture of what's going on in the game.
Exactly. I like to think that we're really making people smarter fans.
Where are we right now?
So we are in the Stats and Analysis newsroom. They do a bunch of different things here. We see a few people watching games, recording stats in real time, and over here we have our home run tracker.
Let's check it out.
This home run tracker is a system that was created by a Navy physicist who currently works for the Boston Red Sox. And so as we input all this data, it runs through a bunch of tests, and it's going to give us the distance of each home run. So we just had a home run hit in the Cleveland Indians game.
They're my favorite team.
Oh, awesome. And so we're going to get the weather for the home run.
Why is the weather important when it comes to this?
If the stadium is humid, it can weigh down the ball and affect how far the ball can travel.
So now we're inputting the weather. 74 degrees.
3 miles an hour, and then the wind direction, it's going south or southeast, it's a 359 degree. And so now we'll track the home run. Okay, so here's the pitch.
Get kind of nervous.
Same.
It's going, it's going, it's going. And
Hits. What'd you get?
I got 4-4-4.
Yeah. 4-4-4.
Nice.
Yeah.
Nice.
So we'll go with a 4-4-4 for a time. And so right now this home run was calculated at 370 feet. It came off the bat at 99.6 miles per hour.
Where are we heading next?
Next, we're headed back to ESPN main campus to prepare for my show meeting. No day at ESPN is the same. My fellow researchers, Zach and I, are coming up with what we think are the critical notes, stats, and trends about games or players that are performing tonight or in the days to come.
So right now it's crunch time.
I feel like there's a lot of crunch times during this shift. One is certainly preparing for the show meeting. This is the perfect balance of being creative and also being analytical.
What do you guys have today?
I think running off that NBA draft stuff, talking about how these prospects will do in their first 2 to 5 years. So something like percent chance to be a superstar versus percent chance to be a bust. It's a combination of his college statistics, his measurables, and Chad Ford's scout rankings.
How much fun is it to be able to do this, watch baseball games, and then break it down to these stats?
I still wake up most days and can't believe that I get to do this for a living.
Yeah, can I pinch you? Or
Yeah,
can I pinch
right.
You? So here we are in Studio X, where the show is about to start.
This looks like Las Vegas.
Kind of.
So we're gonna check out where you sit?
Yeah, I'm just behind this corner. Let's head over there.
Cool.
So this right here is the research station. Normally you have at least one researcher for every show. Sometimes if games are ongoing and the anchors need live updates, somebody's doing what we call scorecards and literally running out these note cards with little tidbits and stats out to the anchors around the corner.
Cool.
I think it suits you.
What advice do you have for young people who want to do what you do?
A lot of people want to work in the sports industry because it's a passion, it's a hobby, it's fun. I think I set myself apart by having that passion also for math and statistics.
This is Sports Center.
I mean, there's nothing like the feeling you get from seeing something that you conceive being said on national television.
So here are a list of the concepts that I will be covering with you today in this video. These are the same concepts on statistics and probability that you will need to know for this class, for the exam. So sometimes I'll have students ask me a question and they'll say, well, I see that you're teaching statistics here in this class, and based upon previous experiences that I have had, previous classroom experiences, I don't know that I like statistics. I haven't had very good experiences with it in the past. And so they'll ask me the question, is supply chain management the same thing as statistics? Or they'll ask, is every class in supply chain management like the statistics class? And that's what they'll ask me. And the answer to those questions are no, not at all. The fact is, there are only a few supply chain management classes that actually utilize statistical concepts like we're going to be using here today. When those are introduced, the assumption is that most students will need to brush up on the statistical concepts, and so there is introductory material to get you back up to speed. The other thing is that the statistical concepts that I'm going to be covering with you today are the statistical concepts that are used within the supply chain management program. So if you can master the concepts that I'm going to be talking with you about today, then you will have no trouble at all with the statistics that we cover in a supply chain management class. Now, I don't know all of the statistical concepts that you have been exposed to, but for really high-powered statistics in a supply chain management, we use software to be able to help us do those calculations and do those sorts of analyses. But the things that I'm going to be covering with you today form the basis for any statistical calculation that we might do. And so, as I mentioned before, if you can perform the calculations that I'm going to be talking with you about today, then you will be well prepared to be 100% successful in our supply chain management program. So let's get started. So in case you missed it, during class, we played a little game where we imagined that we were starting a business where we would go buy donuts in the morning, bring them to school, and then sell them. We were imagining that we would buy donuts for, say, 10 cents a piece. We found a way to get a quantity discount, and then we were able to sell them for $1 each at school, and then that is how we were able to make a profit. But of course, the game is all about determining what your demand is going to be during the day. There are risks involved in deciding how many donuts to buy first thing in the morning. If I buy more donuts than I need during the day, then I'll have leftover donuts that I'll have to throw away and waste at the end of the day, and I will have spent more money than I needed to. If I don't buy enough donuts for the demand for that particular day, then I'll be able to sell all of my donuts, but I'll miss out on extra revenue and profits that I could have had I had those donuts. So it's all about guessing how many donuts I'll be able to sell during the day. Now the problem is that the demand is never exactly the same every day. It fluctuates. Now, there might be an average demand around which the demand fluctuates, but then the actual demand will be somewhat greater than or somewhat less than that average demand, and we never know exactly what demand is going to happen on that day. So let's see if I can demonstrate for you here what we were doing in class. What I'm going to do is I'm going to simulate demand for several days in a row. And of course, we never know what the next day is going to bring, and this really is random demands based upon a particular statistical distribution, and we'll talk about what that means here in a few minutes. So here's how we're going to begin. We'll start with a sort of number line, and then we will watch and see what the demand is for a particular day, and we'll just put a mark on the number line where that demand occurs. So let's see what our first demand is. The demand on the first day is 56. So we'll put a mark here in the block between 55 and 57. The demand on the next day is 49. So we'll put a mark here between 49 and 51. The next day, the demand is 51. So we'll put another mark here in the block between 49 and 51. Next, the demand is 58. So we'll put a mark here. Next, it's 66. Next, 40. Then 34, and so on. For instance, 72, 56, 62, 43, 52, 54, 42, 48, 47, 43, 53, 58. And we keep observing the demand, collecting the data, plotting it on the chart, observing the data, plotting it on the chart. And we keep stacking these up and stacking them up for as many days as we possibly can. And what I've done here is simulated 10,000 days of potential demand. And you can see that once they are all stacked up, that we end up with a picture of the data that looks very much like the normal curve or the bell curve that you have seen in a statistics class. This particular set of data had a demand that averaged 50, so 50 donuts per day, and that's why this graph is tallest in the center. But it can also be greater than 50 or less than 50, and the further away that you get from 50, the less likely it is that you would potentially see that demand. But we do see those demands, just not as often. Now in your mind, I want you to draw a vertical line through the average, right down the center of this picture. So what percentage of the days on this picture or on this graph are above that line or are above average? And you should see that about half of them are. We've got about half of our observations above the average, and half of our observations are below the average. And this is an important statistical concept that we need to know to be able to do the calculations we're going to be doing today. The probability of a demand being higher than average are 50%, and the probability of having a demand that is below the average is 50%. It's like flipping a coin as to whether or not the demand is going to be above or below average. Now, if we started collecting data for the demand for these donuts, and the demand was exactly 50 donuts every single day, it never changed, it was always 50, well, that would make our business model very easy. We would just need to buy 50 donuts every morning, and we would sell them all during the day, and there wouldn't be any additional demand left over. But our real world data is different because the demand can be higher on some days and lower on other days. But we need to have a sense or a way of determining what the spread of that data is. In other words, how high is a high day and how low is a low day? How much does this demand really vary? And that's where standard deviation comes in. So here I have drawn two normal curves, and either of these curves could be representative of the demand for the donuts that we're trying to sell. The diagram that is on the left is spread out really wide, and what this indicates is that the actual demand that we encounter each day could be really, really high or it could be really, really low, but it'll always be centered around the center or the mean, which is 50 for the data that we were looking at. The diagram on the right represents demand that doesn't vary by very much. So again, the center of that curve is the average, and for our data, that's 50. But in this case, the actual demand that we encounter every day doesn't vary much from 50. So maybe it varies from 47 to 53. So it doesn't vary by very much. So the less variation that our data has, or the more consistent that it has, the more narrow this curve will look. And the more spread out, or the more variation that we encounter in data, the wider that the curve will look. And we actually have a measure to determine how wide that spread in the data is, or how much variation that is. So first, let's define some terms that are on these pictures. The first thing we've already looked at is the average. Now that's the solid line that goes right down through the middle of both of these curves. That's the center. It's called the average or the mean. The Greek symbol for it is mu, which sort of looks like that funny looking U shape with the tail. We might also consider it to be demand. When we're talking about supply chain management, that center is the demand, or the average demand. Now the standard deviation is what measures how much the data varies. Now we won't need to calculate standard deviation. That'll always be given to us in problems in supply chain, and we have ways of calculating that using some software that makes it very, very easy to do. But standard deviation measures how much the data varies. So the more that our data varies, or the less consistent that our data is, the larger this number will be for standard deviation. And then the more consistent our data is, or the less variation there is, the smaller that number, standard deviation, will be. But for any set of data, once we've determined the standard deviation, that is the standard deviation. Now the symbol for standard deviation is sigma, which kind of looks like the letter O with a line going over the top of it. That's sort of what it looks like, but I have a picture of it here, and you can see that symbol. So the standard deviation within one of the diagrams, each diagram doesn't change. So for instance, the first dotted line that we see to the right of the average is the average plus 1 standard deviation. And then the second dotted line is the average plus 2 standard deviations. And the third line is the average plus 3 standard deviations. And you can see each one of those lines is the same distance from one another because the standard deviation doesn't change. Now this is really significant because I'm going to show you how using this information we can calculate all kinds of very useful probabilities that would be useful for any of us regardless of our major. For instance, for accounting or finance, we will be able to calculate the probability of hitting our profit or revenue projections. For sales, we'll be able to calculate the probability of hitting our sales targets or the probability that we will have enough product to be able to serve our customers. We will be able to calculate the probability that we will run out of donuts on a particular day. In other words, having a stock out. And of course, this is very important if we're trying to manage our customer perceptions. But before we learn how to do any of these calculations, let me just make sure that you're still following along. Now, in the video, I want you to really pause in the video and try to answer these questions on your own. I think that you'll be able to answer these, and these are representative of some of the questions that may be on our upcoming exam. So the very center of a normal curve is called the average. Now, what percentage of observations will we see above the average? 50%. Now, the number that represents how much the data will vary is called the standard deviation. And data that has more variation will have a standard deviation that is higher. Of course, you can probably guess at the inverse of these questions. For instance, about 50% of our observations will be below the average, and data that has less variation, or data that is more consistent, will have a standard deviation that is lower. The reason that all of this is useful to us is that there have been some really smart people in the past who have already calculated probabilities associated with each of the lines on this chart. Now, you already know that 50% of our observations will be above the center or above the average. But look at the line that's way over there on the far right. See that? That's the average plus 3 standard deviations. And you can count those lines. 1, 2, 3 lines out there. That's 3 standard deviations above the average. You see how there's just a little itty bitty tail, a little bitty triangle that's there right there at the edge? See how small that is? That little triangle is less than 0.1% of the total diagram. So people have already calculated that there's less than a 0.1% chance of having a demand above that 3 standard deviation line, above 3 standard deviations above the mean. People have already calculated that above the 2 standard deviation line, so that's 2 standard deviations above the mean, that's the line. If you look at the center and go to the right, 1 dashed line, and then the second dashed line, that's the average plus 2 standard deviations. See how there's a little larger triangle there of the curve? People have already calculated that about 2.2% of observations will be above this line. And then above the 1 standard deviation above the mean, that's the mu plus sigma, the average plus 1 standard deviation line. See how there's a much larger triangle? It's sort of a triangle. I know it's got a curve on one side. But people have calculated that about 15.9% of observations will be above this line. And so we can use this information to calculate all sorts of probabilities as long as we know the average and the standard deviation. And those are 2 numbers that we will always give you in these types of problems. In order to do the calculations that we will need to do for this class, there is one more number line that we're going to need to put on this chart, and it is a number that is called Z. Now, Z just represents the number of standard deviations away from our average. And so this number line, sort of the center of this number line, where Z equals 0, Z equals 0 right at the average. So you see the symbol mu right in the center of our chart. That is going to be the Z equal to 0. Then standard deviations to the right or greater than the mean will be positive Z numbers. And standard deviations to the left or standard deviations below the mean will have a Z that is less than 0. And here's what that number line looks like. Right at the average in the very center, z equals 0. Then for every standard deviation to the right or greater than the average, we increment up. A z of 1 is 1 standard deviation above the mean. A z of 2 is 2 standard deviations above the mean. And then on the other side, for instance, a z of -3 is 3 standard deviations less than the mean, 3 standard deviations below the mean. And this really is a number line. So we don't have to have just whole numbers for z's. We could have z's that are between whole numbers. So we could have a z of 1.3 or 0.2 or -2.7. And the thing that makes this useful is that there are some really smart people who have already calculated the probabilities for all of these z values. All we have to do is be able to look the probabilities up in a chart that is called the z-table. We have provided a z-table for you to use when you're doing practice problems, and that is the same z-table that you will use in all of our supply chain management courses and on this exam. But before we can look up probabilities in our z-table, we need to know how to calculate z. So this is the formula for z. Now, z is just the number of standard deviations away from the average, and there's probably many of you who could figure this formula out on your own, but I'm going to give it to you and print it out for you on the exam to make it easy for you. So let's go through each one of the variables here. So z is the number of standard deviations away from the average. We've indicated that that's a number line where a z equals 0 is exactly at the average. And then there's negative z's below the average and positive z's above the average. And we're going to be calculating this z number. X is the value for which you would like to calculate the probability. Now I'm going to show you what that is all about and where we get X in a minute, but that will be given to you on these problems. Mu in the formula is the average, and this will always be given to you in these problems. Now, in our supply chain management classes, there may be times when you're asked to calculate the average, but I think that that's relatively easy for most people to calculate the average of a set of numbers. Just add them up and divide by however many numbers you have. Sigma is the standard deviation. Remember, this just indicates the spread of the data or how consistent the data is. Less consistent data or data that has larger variation will have larger values for sigma, for the standard deviation. And sigma or the standard deviation will always be given to you in these problems. So this is just the way that it will be given to you on our exams. I'm going to give you the average and the standard deviation, and I'm going to ask you for the z that's associated with a particular demand. So for instance, from our simulation that we just did, the average is 50 and the standard deviation is 10. Now you did not need to calculate these numbers. These are things that I'm just giving to you in this problem statement. And then I may ask, well, what is the z that is associated with a demand of 67 donuts? Well, in this case, 67 is X. That's the z that we're concerned about, or that's the number that we'd like to calculate a probability related to. So what is the z associated with the demand of 67 donuts? Well, we just plug these numbers into the formula. 67 is X, mu is 50, and sigma is 10. So 67 minus 50, we do that and then divide that by 10, and we get that to be a 1.7. What is the z associated with a demand of 33 donuts? Same way. 33 here is our X. That's the number that we're concerned with calculating a probability for. And so we plug those numbers into the formula. X is 33, mu is 50, sigma is 10. So 33 minus 50 divided by 10 is negative 1.7. And this would be z. And then we would look those z values up if we were concerned with probabilities in the z-table. And I'll show you how to do that in a few minutes. But first, why don't we practice doing this? Let's give it a try. Now here are 4 examples of problems that are similar to problems that you might find on the exam where you need to find z. why don't you take a few minutes, pause the video, and find the problem here that relates to you the most, or the one that you feel you can relate to the most, and calculate z for the values that are shown in that particular problem statement. So I'll give you a second. Why don't you pause the video, and then I'll come back and I'll tell you the answers. Well, I hope you had the opportunity to try this out on your own. And for all 4 of these example problems, the z value associated with all of these is 2.2. Now, each one of them has a different average, each one of them has a different standard deviation, and each one of them has a different value for x. And but once you do the math on each one of them, you get a z value of 2.2 for each one of these. So hopefully you were able to get those. If you weren't, please see your instructor or one of the instructional assistants, and they'll be happy to show you how to calculate each one of those. Now I'm going to share with you the secret to reading any normal table. Now I don't know what type of normal table you've been exposed to in the past, in your past experiences. There are many different normal tables, and each one of them have different probabilities and look a little bit different. There is only one that we are going to use for this class, and I'm definitely going to teach you how to use that one. And that one normal table is the same one that we use in all of our supply chain management courses. So it's the only one that you're going to need as a supply chain major for sure. But I want to teach you the secret to reading any normal table that will help make more sense out of any normal table that perhaps you have used in the past. And the secret is that every normal table has a picture at the top of the table that shades what probabilities are included in the table. So here's an example. Let's say that we calculate z and we find z to be 1.18, and we go to look that up in our z table, a z of 1.18. Now, do you see the curve that's there on the far left? That looks like there's a stripe that is shaded there. And you see we have z of 1.18 that's labeled there on that diagram. And then there's that shaded region. The shaded region is from the average all the way out to the z of 1.18. And the probability of that shaded region is 0.38100. And that's what you would see in that particular table. That diagram on the left, that happens to be representative of the table that we are going to be using in our class here and in all of our supply chain management classes as well. Now, there are other tables as well. So for instance, there's a table that has a real large portion of the curve that's shaded. That's the one there in the center. And you see there, it's shaded all of the curve that is to the left of z equals 1.18. And if you were to look up the probability in that particular table, you would find a probability of 0.88100. And you might say, well, why is that probability different? Well, look, the probability 0.88100 is the same as the probability there that's shown on the left, that one that's 0.38100, plus half of the curve. So we have that stripe plus half of the curve. So 0.38100 plus 0.5 equals 0.88100. Now there are other tables that have a diagram like you see there on the right, where just that little baby tail that's way off to the right is shaded. So that is the area of the curve that is greater than a z of 1.18. And if you were to look up a z of 1.18 in that particular table, you would get a probability of 0.11900. But that's just the same probability that's left over once you take out the stripe that's in the first diagram that's over there. So you see, all 3 of these tables give us the same probabilities. It's just that they're going to be showing us probabilities associated with a different portion of that curve. The one that we're going to use is the one that's shown there on the far left. So the probabilities we'll see in our table will always be the probabilities that are from the average, the center of the curve, all the way out to z. So here's an example of a problem similar to something you might see on the exam. I'm asking here, if z equals 1, then what is the probability associated with z? So that's all we're doing is looking up the value of z in our table, and this is the normal table. Now this is the same normal table that you'll see on our exam for this class. It's also the same normal z table that you would see in your supply chain management classes. So we read z on the left side of the chart. So you see on that table, it has z values, and they start there at 0 in that vertical column, and they go down. It goes 0.1, then 0.2, 0.3, 0.4, 1 and 2 and 3 and 3.5 and 4 and 4.1. So all there in a vertical row. That's where we read z. And the z of 1.00, we will find the probability associated with that, we will find in that first column right here. So the probability from our table that's associated with a z of 1.00 is 0.34134, or 34.134%. But what if we're looking for a z of 1.02? Now here's how you read the normal z table. See the decimal values that are at the top of that chart? 0.00, 0.01, 0.02, 0.03, 0.04. These are the values that you will find in the hundredths place as we're looking for those values. So for instance, for a z of 1.02, we will look at the z of 1.00 and we will add to it 0.02. So we're going to look in that second column. I'll show you. So we look in that second column and we find that the probability associated with a z of 1.02 is 0.34614, or 34.614%. Okay, now you try this next one. What if we're looking for a z of 2.27? First, find z equals 2.2 on the left-hand side, and then move to your right until you get to the column that is headed 0.07, and that will be the probability associated with a z of 2.27. So were you able to get that? To find the probability from our table that's associated with z of 2.27, move down that first column until we get to z of 2.2, and then move over until we get to the column that's labeled 0.07, and that will be the probability associated with a z of 2.27, which in this case is 0.48840, or about 48.840%. Okay, let's try this one. Find the probability from our normal z table associated with a z of negative 3.4. Now one thing you'll notice from our z table is that it only contains positive z's. So how are you supposed to find a probability for a negative z? Well, let's take a closer look. Remember that the normal curve is symmetrical, so it looks exactly the same on the left as it does on the right. So even though our table of probabilities, our normal z table, only contains positive z's, it would look exactly the same, with exactly the same set of probabilities, if the normal curve were flipped to have negative z's. So we can actually use the same table for either positive z's or negative z's. Just remove the negative and take a look for the z value in the table. So in this case, the probability associated with a z of negative 3.4 is 0.49966, or about 49.966%. Now technically, from our table, this probability is the probability from the average, the mean, out to z, and the diagram on the table shows a positive z value there. But remember, this table would look exactly the same even if this diagram were flipped. And so the probability 0.49966, it applies to either a z of 3.4 or a z of negative 3.4. In our case, this is the probability associated with a negative z. Hey, by the way, what is the probability associated with the white section of the curve to the right? In the diagram that I've shown on the bottom right of the slide, what is the probability of the entire white section that's to the right of that circled region that I have there? You should know it's 50%. That's half of the curve. Remember, half of our observations, or 50% of our observations, will be above the average, and a half of our observations, or 50%, will be below the average. Now I want to give you a step-by-step plan for solving any probability calculation that involves the normal distribution. Now I've got to tell you, I wish someone had told me about this when I was taking statistics. If you follow these instructions, you will not have to guess at how to calculate the answers to these questions. You will know. You will be able to solve the several types of questions that we will explore in this class, and you will also be able to solve a variety of problems that you might encounter in your future classes or in your careers. So let's take a look. Okay, the first step is to draw a blank picture of the normal curve. It is very important that you draw the picture as you begin to solve these problems. If you take the time to draw the picture, you will be much more likely to get these problems correct. I'll have students many times that will bypass this step of the process, and because they think that they just know how to calculate these sorts of problems and they've done enough of the practice problems that they'll get them correct, and many times they will get them wrong. Drawing the picture is really the key to being able to make these problems easy. So start by drawing a blank picture of the normal curve. The next step is to identify the average and the standard deviation of the data from whatever the problem statement is. For instance, on an exam problem, the average and the standard deviation will always be labeled and will be given to you in these types of problems. You should now write the number that is the average at the center of the normal curve that you have drawn. For instance, in our example, we've been selling donuts and the average demand is 50. So we'll write 50 at the center of our normal curve. Next, identify the number for which you will be calculating z. Now this will be the number for which you're curious about a probability. So as an example, if I were to ask you, what is the probability that I will sell more than 75 donuts? Then 75 is the value for which we will be calculating z. In the formula, this is the value x. So on the bottom of our curve, it's a number line. So for instance, with this example, I'm curious about the probability of selling more than 75 donuts. So 75 will go to the right of our average. But if I had asked what is the probability that I will sell more than 30 donuts, then we would write 30 to the left of 50, because that's just a number line on the bottom of our curve. Next, shade the portion of the normal curve that represents the probability you are trying to find. So if you're asked to find the probability of more, you will shade to the right, and if you're asked to find the probability of less, then shade to the left. In this case, in our example, I asked, what is the probability that I will sell more than 75 donuts? So I'm going to shade the area of the curve that represents more than 75 donuts, or to the right on my number line. Next, you will calculate z using the formula z equals x minus mu over sigma, which will be given to you, of course, on the exam. And then you look up the probability value from the normal distribution table that's associated with z. You're going to actually write this probability number on your picture and then shade the region of the curve that matches that probability. For our class, that portion of the curve will always be from the average or the center of the normal curve out to the number for which you are calculating a probability, either to the right or the left of the center line. Take a look at the blue shaded region that I put in this diagram. Notice that that blue shaded region matches the shaded region that's at the top of our normal z table. So you can go back and take a look at the z table. Those two shaded regions match. And so you're just going to shade in that region and write in the probability that was given in the table. Finally, you're going to need to determine the probability that's associated with the shaded region that you shaded back in step 4. You're going to use your knowledge that half of the normal curve represents a 50% probability to either add or subtract to determine the probability that you're trying to find. So in this example, we found that the blue shaded region is 0.49379, but what we wanted to find was the probability associated with the black region of the curve. And so what we're going to do is take 0.5, which is the entire right-hand half of that curve, and subtract out the blue region, 0.49379, and we'll be left with the probability associated with the black region of the curve. In this case, 0.621%. And we follow these same 6 steps to solve any of the probability problems that will be given in this class. All right, let's review some of the basics. What do we call this center line on our normal curve? That is the average, or the mean of our distribution. That's the average value that we would tend to see. In our case, we're talking about demand, so that represents our average demand. Do you remember the symbol you use for the average or the mean? It's mu. It's that funny looking U with the tail on it. And then if this is the graph of the demand of donuts, what is the probability that tomorrow's demand will be larger than the average? And you should know that it's 50%. It's always a 50% probability of having an observation above the average or having an observation below the average. All right, what do we call this distance on our normal curve? The distance between these two dashed lines. That is a standard deviation. And do you remember the symbol we use for standard deviation? It's sigma. It's the sort of looks like an O with a line going across the top of it. And then if a set of data has a lot of variation, will the standard deviation tend to be a bigger number or a smaller number? Yes, it will tend to be a larger number. Lots of variation will give us a large standard deviation. Small variation or very consistent data will give us a small standard deviation. And the standard deviation will always be given to us. We will not have to calculate that. All right, how about this line? This is one of our standard deviation lines. What is the value of z associated with the line that's being pointed to here with the red arrow? That is a z equal to 1. Remember, z just represents the number of standard deviations away from the mean, and this dashed line is one standard deviation away from our mean. It's one standard deviation above the mean, and so that's a z of 1. And we will always calculate z using the very simple formula that I've given you in class and that you'll be given on an exam as well. Now there are only 2 types of probability and statistics problems that you will need to be able to calculate for this class. And so I want to walk through with you how to calculate each of these 2 types of problems. And for all of these, we are going to use these 6 steps to solve them. Have you ever gone to the grocery store to buy your favorite item and they were out of stock? They didn't have it in stock? Well, what happens when you go to that store and repeatedly you look for that item and they don't have it? Right? You go look somewhere else. So we want to try to avoid that problem, both from a sales perspective and a supply chain management perspective. So what we would like is we would like the service level to be very high. In other words, we want there to be a very high probability that when the customer comes to buy our item, that we will actually have that item in stock for the customer to buy. So that is called the service level. Now we could say, well, I'll just keep inventory at the average demand level. Whatever the average demand, I'll have enough inventory to cover the average demand. But remember, half of the time the demand will be less than the average, but half of the time the demand will be more than the average. So actually, we won't have enough inventory to cover our demand half of the time. That's known as a 50% service level. Now, no company wants to operate at a 50% service level. You would be really losing customers. And so what we would do is we would work with sales and work with the management team, work with supply chain management, and determine what is the appropriate service level. And then what we're going to do is we are going to set an inventory level to match whatever service level we're going to be looking for. So service level is a probability or a percentage that represents what is the probability that the company will have enough inventory to handle upcoming demand, or what's the probability that our inventory will be higher than the upcoming demand, or what's the probability that the demand will be less than whatever inventory we currently have. And so the current inventory level in these problems will always be greater than the average demand. That's how these problems will be set up for you. So if we're looking at our diagram for service level, we will need to find the probability that the demand will be less than our current inventory level. So we're going to be looking for the demand that is to the left of our current inventory level. In the diagram here, it's both the black and the blue sections of the curve together. Now, our normal probabilities table will only give us the probability that the demand will be between the average and the current inventory level. So that's that blue section of the curve. That's what the normal probabilities table will give us. So in order to find the total probability, the total service level probability, we will need to add the other half of the curve. So service level will always be the probability that's associated with Z plus 50% or plus 0.5. Let's see how this looks in a problem. So here's our first problem. Historically, demand has averaged 10,000 units per week with a standard deviation of 1,000. The company currently has 12,750 units in stock. What is the service level? Okay, to start out, first draw a blank normal curve. And you can do this on a piece of paper there in front of your computer. Draw a blank normal curve. That is step number 1. Next, we need to identify the average and standard deviation of the data from our problem statement. So can you identify these? The average is 10,000 and the standard deviation is 1,000. So now write the number that's associated with the average at the center of the normal curve that you've drawn. Next, identify the number for which you will be calculating Z. So this is the number that we're asking about a probability. So it's asking what is the service level, considering that we currently have 12,750 units in stock. So the value for X that we will use in the formula for Z is 12,750. Next, shade the portion of the normal curve that represents the probability that we are trying to find. In this case, for the service level, remember we're always going to shade from the value X, in other words from 12,750, all the way to the left. So the entire curve from 0 all the way to 12,750. Next, we will calculate Z. Now you have mu, sigma, and X. So you take a minute, pause the video, and you calculate Z. So we find that Z is 2.75. Now use the Z table to find the probability that's associated with Z. This will be the area of this curve that I have shaded blue. So take a minute, use your z-table, and find the probability associated with a z of 2.75. So the probability associated with the z that we've calculated for our problem is 0.49702. But this is just the blue portion of the curve. Remember, for service level, we are going to need to find the probability from everything to the left of z. In this case, we have to include that black portion, which is half of the curve, or 0.5. So in order to find the probability associated with our service level probability, we are going to take the probability that we just found, which is the blue portion, and we're going to add to it the black portion, which is 0.5. So add those two numbers together. And as you can see, this gives us a service level of 0.99702, or about 99.7%. And this means that if we have inventory currently at 12,750, we have a 99.7% probability that we will be able to meet the upcoming demand. So there's one more problem type that we'll need to know how to do for this class. Let's take a look. Now, a few minutes ago, we calculated the service level probability. Service level is the probability that we will have enough inventory. So we were always calculating to the left of z. We were calculating the area of the curve to the left of z, the probability of being less than our current inventory. Because our inventory levels, we are assuming, are always greater than the mean, greater than the average demand. For stockout probability, the situation is different. Stockout probability is the probability that we will not have enough inventory. So with this, we're always going to be trying to find the probability to the right of wherever our current inventory is. So there are two scenarios that we will use for calculating the probability of a stockout. Now, typically, the situation that we would like to be in is where our current inventory is greater than the average. That'll give us a very low probability of a stockout. We know that the stockout probability will be less than 50%. And so we will be calculating, just as it shows in the curve there on the left, we will be calculating the probability of the little tail, which is the probability to the right of z, or to the right of the inventory that we currently have. And that's when the current inventory is greater than the average. But there's also situations in supply chain where our current inventory falls less than the average. Now that's a bad situation to be in. When our current inventory is less than the average, we know that we're going to have a very high probability of having a stockout. In fact, that stockout probability will be greater than 50%. And when we see it in the curve, it looks like the diagram on the right, where our current inventory is to the left of the mean, and we will be calculating the probability to the right of that value, or to the right of the z that is calculated at that value for that inventory. So for an inventory stockout, we are always looking for the probability to the right of z. As long as you draw the diagram at the beginning of a problem statement, then you'll always be able to figure out how to calculate these. When we're calculating the service level, then you will shade the region to the left of z, or below z. And when we are calculating the stockout probability, you will always be shading your diagram to the right of our current inventory, or to the right of z, regardless of where that occurs in your diagram. So maybe an easier way is to deal with it with a couple of examples. So let's take a look. Here's our first example. So historically, demand has averaged 10,000 units per week with a standard deviation of 1,000. So you see those values are given to you, and it says that the company currently has 12,750 units in stock, which is greater than the average. It says, what is the probability of the stockout? Well, right away we know, because the company currently has more inventory than the average, then the probability of a stockout will be less than 50%. If our inventory was exactly the average, then a probability of a stockout would be 50%. But since we have more inventory than the average, we know that the probability of a stockout will be less than 50%. So that's our first indication here. We draw the diagram, the bell curve, the normal curve, and we identify the mean and the standard deviation. So you should be able to see, it says here the average is 10,000, the standard deviation is 1,000, and we can mark the center of our curve with the number for the average, which is 10,000. Next, we're going to be identifying the number we're going to be using for x in this formula for z up above, and that's the number for our current inventory. So the company currently has 12,750 units in stock, so that is going to be the value we will use for x. We can then plug in those values in the formula and come up with a number for z that we'll use in the z table. So here are the values for the average, the standard deviation, and x. We plug those numbers into the equation for z, and we can find z. Now, because x is greater than our average, because the company currently has more inventory than the average, we know that z is going to be a positive number. It's going to be to the right of the average. So let's take a look. So here's z. And see how I have shaded the region of the curve to the right of z. Z is at 2.75. At the center of the curve, z would be 0. So a z of 2.75 is to the right of the center. And then I shade the region to the right of z. That's the portion that we're going to try to find. Now, the next step is to look up the value for z in the normal z table. So look up the probability associated with a z of 2.75 and see if you can figure out where to label that in our drawing. Here's the probability associated with z. That probability is the white space in this diagram between the mean, which is the center of the curve, and our z, which is out there to the right. So it's just that strip between the mean, the average, the center of that curve, and then the beginning of that little black triangle that I've drawn in that normal curve. That's where that probability is. So we know that probability is 0.49702. We then also know that the entire probability for that half of the curve, the probability of having demand greater than the average, is 50%. So we know that the whole probability of the right-hand side of that curve is 0.5. And we can easily then find the little tail by taking 0.5 minus 0.49702. And we end up finding out that the probability of a stockout is 0.298%. So a really small percentage probability for stocking out if we have 12,750 units in stock with the average only 10,000 and a standard deviation of 1,000. Now let's look at the other situation we need to be able to calculate. So here's our next example. Very similar. Historically, demand has averaged 10,000 units per week with a standard deviation of 10,000, but this time the company currently has 8,750 units in stock. Now already, you should know this is not a good situation to be in. The company has fewer units in stock than the average. So we know that the probability of a stockout is going to be greater than 50%. So should be a larger number than 50%. It's asking, what is that probability? What is the probability of a stockout? Well, we're going to follow the same pattern that we have for the other problems. First thing is to draw the diagram. We will identify the mean and the standard deviation, which have been identified for the other problems as well. So the mean is 10,000 and the standard deviation is 1,000. But this time the number for x is the amount that the company currently has in stock, so 8,750 units. That's the value for x. So here we see the values for the mean, mu, the standard deviation, sigma, of 1,000, and then x, 8,750. We can then enter those numbers into our formula for z. So just enter in those numbers for the values in the formula for z, and we come up with the value for z that corresponds with 8,750 units. Now, because the current inventory is less than the average, since it's less than the average, if we look at that on a normal curve, you can see that we should expect the z here to be negative. So negative values for z are values that are below average, and here we have inventory that is below average. So let's see what z turns out to be. So sure enough, z is negative 1.25. So that's what I've drawn on this normal curve. You can see the average is at the center of that curve. It would be the line straight down the center of that curve. Z of negative 1.25 is someplace to the left of that. And I have shaded the region of that curve for which we're trying to find the probability, which for a stockout, remember, will always be to the right of z. And so I've shaded all of that curve to the right of z, to the right of that negative 1.25. So now we can look up the probability associated with z of negative 1.25, which of course is the same as the probability of z at positive 1.25. We'll look that up in the normal table. So let's do that. And we see that that probability is 0.39435. Now we need to identify where in this curve is that 0.39435. And the 0.39435, that probability, is the area of the curve between the center of the curve, so the mean, the very center of that curve, and negative 1.25. So it's the little strip of the curve between the center of the curve and out to the left of where z is at negative 1.25. Now that's just part of what we need to calculate. We also need the entire other half of the curve, and of course half of our normal curve is 0.5. So we need not only this 0.39435, which is to the left of the average, we also need the 0.5, which is to the right of the average. And so to find the probability of a stockout, we just add these two together. And we find that the probability of a stockout here is 89.435%. Certainly that is larger than 50%, and that is not a good situation for this company to be in. They have fewer units than the average demand, and so they have a high probability that they're going to end up having a stockout. So we've covered a lot today. We've covered the basic principles of a normal curve, including the average, the standard deviation, and how z represents the number of standard deviations away from the average. And we've learned how to sketch or draw those out on a sheet of paper. We learned how to calculate z using the standard normal table. And then using the 6-step process for solving probability problems such as this, we learned how to solve two different types of supply chain management probability problems. And these are the two types of problems that will be on our exam. One is calculating the service level given a certain inventory level, and then the other is calculating the probability of a stockout. And there were two situations there. One was when we, probability of a stockout when we had more inventory than the average, and calculating probability of a stockout when we had less inventory than the average. Now I want to let you know the reason that we have provided this video in addition to the classroom experience that you had already is to give you an opportunity to go back through your notes and go through it at your pace. So you're free to watch this video as many times as you'd like, rewind, be able to see parts over again to try to understand it a little better. Then I want to let you know there are many practice problems and the answers that are available on Blackboard for you. I want to strongly encourage you to practice using the practice problems that are available. The way that I would suggest doing it is to take the practice problems, perhaps even print them out and cut them out, and then scatter them around and pick them up randomly, because of course randomly is how you'll end up seeing them on the exam, and then see if you can solve them using the formula for z and the Z normal table, which will be given to you on the exam. That'll be great practice for the exam. And I want to let you know, use these practice problems that we provide for you on Blackboard. These practice problems are set up exactly the way that they will appear on the exam. We, the instructors, want you to do very well on this portion of the exam. We really want you to understand this fully. And so we aren't trying to trick you in any way by wording problems in a way that you have never seen before. They will be worded exactly the same that you see them in our practice problem sets. And so use those for practicing and getting ready for the exam. Of course, our instructional assistants are always available to walk through these with you as well if you feel like that you need extra help. And we certainly hope that this has been helpful for you and that it will help you be better prepared to be successful in all of your careers.